two topics that you want to be careful with. So here's scalar multiplication. Means to like expand. It's a kind of like a stretch. You're just making every value that much bigger. So it's a different kind of multiplication. So this becomes as simple as, hey, that's 15 because negative 3 times negative 5, negative 3 times 8, you distribute. So this is the fun one. It's called scalar multiplication. All the vectors that we just did. So I know that you're just fresh from the world of vectors, which you got to take a look at. You can actually arrange vectors into, there we go. I'm not graying at you, I'm graying at my computer. You can put vectors into columns and put their x and y components, or rows, depending on how you organize it. So if you call this your x and y, you can put vectors into matrices where the x and y component are in there. That's a common way to organize your vector data, is to put it into matrices. Okay? So those, good things. Next one, same idea, distribute. And when you add, it's component to component. So these get pretty fast, as you can imagine. Nothing fancy. Negative 30, got 15, got 5, and somebody's going to say if that looks funny. Halves are fine. So 3, you get 0, half a 0 still 0, 3 halves, and negative a half. Adding it together from there, no big deal, kind of a no-brainer. You have negative 10 and 3, obviously negative 7, and they have fractions to deal with, which is fine. Negative 30. 15 take away 3 halves is like 1 1/2, so it's 13 1/2. And then 5 take away a half is like 4.5. That's as simple as you might thought it was. It is. To the block of info, if you're going to multiply matrices, it's more complicated, like matrix times matrix. So I'm going to leave this box unfilled for a minute because I know what it's trying to say, but it's easier to show you and then come back. Here's the deal. You can only multiply matrices that have, if I say, hey, what's A times B? That's the notation for it, so look really carefully. This means matrix A times matrix B. The result, the product, we'd call it, is C. And you guys, this is the part, if you're not paying attention and your phones are up, put them away because you need this. The insides have to match. So the row of the first has to match the column of the second. So these got to match. So A times B, that 4 and 4 match, must match if you're going to multiply. So match if you are to multiply. Now, if you multiply, which I'll show you in a minute, you'll see why that comes up to be true. So I can multiply these, I can get a result. So last year, like I said on the AC tape, there's a problem that said, hey, could you multiply these two matrices?
Matrices.
And if you looked at their rows and columns, a 4x3 and a 4x6, your answer would be, no, I cannot multiply these two because my row and columns, when you put them side by side, and it has to be that order, A times B, the column of the first one and the row of the second one, these don't match. And if they don't match, you just cannot multiply. And you'll see why here in a minute. It's kind of like putting together Legos of different sizes if you want them to line up for multiplication. Here is the process of multiplying. So if I go get A and B, which I think are down below in a situation. So these are all, can you do it? Do the dimensions work? So it's a quick test. Do these match? You say, yes, I can multiply those. Can do. Then I look at these, they match. Can do. The only one that didn't work out was that number 3 because the 3 and the 4 didn't match. That's the dimension component that's required. And it does show up on the ACT, so be prepared for that. So I want to multiply these. So I'm already down to part 8, and it says multiply these two together. Because I want to cruise, get to the fun part. CD, can it be done? This is a 2x3. This one on the right, the D column or the D matrix, is a 3x2. If I'm going to multiply C times D, you're looking at do the inner components, the row of the first and the column, the column of the first and the row of the second match, and they do. We can do this one. So even before we start, you know you can. Here's the goofy part. it's color coded. So you ready for this? To multiply, you actually take the elements of this row in the first one times the elements of this column here. We're going to line them up and multiply them. So for instance, just mentally, I'm going to get 18, 8, and 6. 18, 8, and 6. But you know what I'm going to do with those when I'm done? I'm just going to add them up. 18, 8, and 6 are going to get added to make one value that goes inside this next matrix. Here's the other part of matrix multiplication that's important to know. When I go up to that problem up above, the reason that those had to line up, this is why the 3 and the 3 had to match, is because the 3 elements that you see here have to match the 3 elements that you see over here. They actually have to physically line up when you turn it sideways and multiply them together. So you always take a row times each of the columns in the next one, and if those numbers don't match, they don't line up properly. So that's why those had to match. That's the underlying reason. So I'm going to go back. When you're done, though, what you get is important. So going up here, remember I said you can do, so all of these you could do. The end result is you always get a matrix of size, if you can do, of the outer two pieces. So in number 1, we're going to get a 3 by 5.
Yeah, where are you?
Just up above.
Okay, but we can't yet.
Keep on going. It's above 8 systems. You'll find it in there somewhere. Page 5?
We want to watch you write.
Is it not writing?
No, you were zoomed in.
Yeah. Whatever I got on my screen, you see on their screen too, so it should be the same. You'll have to let me know. I'm on page 5 and on number 1 at the bottom. Something like that. Maybe I'm answering the wrong question, but this is a 3 by 5. Because the elements on the outside, when you multiply it together, become the size of the resultant product matrix. So I'm going to multiply A times B. I can because the inner pieces match, so that my row matches the column when I multiply them together. What I'll end up with is a 3 by 5 matrix. So next one, if I scroll over, I can do number 2, and I'm going to get a 1 by 7 as the size of my resultant matrix. Don't worry about number 3, couldn't even do it. And then finally number 4, you're going to get a 1 by 1. 1 by 1 matrix.
So can that even happen?
One number. It's kind of fun.
But then why is it?
It just ends up giving you a number, a single number. Isn't that cool? So 1 by 1, and we'll show you what those look like too. That's all the lining up piece. The process of multiplying matrices, if you want to get into the why and the how, it's actually kind of an interesting process, but if it has to do with something like the number of pizzas and the pricing of those things, when you do a matrix multiplication, the result is actually looking at a means of optimizing in quantities and total costs and things like that, but we could kind of dissect it someday and it'd be kind of fun. But for now, let's do matrix operations. To multiply and get that do you realize that we're going to get a 2 by 2 when we're done?
Yeah.
This is going to be a 2 by 2. So I'm going to make a matrix. I'm going to put little blank spaces for my 2 by 2. 2 rows, 2 columns. All my results go in there. And that's important when you're multiplying. Set up your resultant matrix so you know how many numbers you're going to put in there. The very first number I put in is see that row I circled and that column I circled? I said I'm going to multiply all their matching numbers and just add them up. That result is going to go in this very first box. Okay, this is the first thing I'm going to do, right there. Okay, so I'm going to write this one out because I have the means to kind of zoom in. But I'm going to do -3 times -6, 4 times 2, and 2 times 3, and I'm going to add them all up. Okay, so
Say that again.
I'll write it too. I'm just giving you kind of a heads up. See that -3, I'm going to multiply by the -6. You might want to watch because it might be tiny on yours. You might need more room. And then I'm going to do the 4 and the 2 and multiply them. I might even expand mine a little bit. I probably will. And then I'm going to do the 2 times the 3. I thought I could read.
That was a really small space.
Yeah, you're doing a lot. There's a lot of people outside of our class right
No, what are you doing? Is that Blake?
Okay. So there are, so you see those elements all lined up? I just wanted to have them in the same screen so you could kind of see where those come from. Negative 3 times 6, the 4 and the 2, and the 3, the 2 and the 3. The feeling is you pick this one matrix up, the row matrix, and you turn it on its side and you line it up with the column. You multiply their components and add them up. We're going to get one number eventually in there. I'm going to put it in a minute. We do this again with that same row because we have another column to do this to. So now I'm going to take it times this next column. Got to do it there.
Ryan O'Hara, please report to the office.
Okay. So that one I got to squeeze in there as well. That ends up being negative 3 times 4. And then I add that to, what is it, 4 times 3? You see kind of the tedium kicks in here real fast, really fast. And then 2 times negative 2 to close it. Line them up, multiply their matching parts. Make sure you can see where they're at. All the row elements times all the second column elements, add their result, we'll get a single number. We get to do it again. Next row. Let me warn you, I don't make you do by hand multiplication for very large matrices because that would be a big kind of pain and a lot of time and that you don't need to spend. So I'm going to do this again. That 5 times negative 6, matching up that 0 times 2. If you can't see where these numbers are, well, you say something because I want to make sure you find them. And then the 4 times the 3. Line them up, multiply their parts, add them together. They get, that row gets multiplied by the other column. And then it's off to the races. Takes a while. Oh, my Lanta. And then 4 times 0 times 3 is 0. And then last one is 4 times negative 2. There'll be lots of, you can do it mentally in some cases and things are relatively easy, but those are all the elements multiplied together and added. We need results for all those. So in the end, you're going to write just a 2 by 2 matrix that has the results of those in it. That's all it's going to end up being. So this simplifies down, and we'll use our, I'll show you how your calculator does it in an instant and you'll be excited that it does. So we have negative 18. I'm looking at the very first one. Negative 18 and 8, negative 10, plus 6 more. We're looking at negative 4. You can double check it. I have negative 12 and 12 is 0 plus 4 more. The bottom left, negative 30 and 0 is negative 30 plus 12, negative 18, and then finally 20 plus 0, take away 8. 20 take away 8. That's it. So you go to your calculator and say, can I do it with my calculator? Oh, yeah. Okay. Hopefully I can get the screens to line up a little bit. Squeeze this over. Put this one here. Terribly time consuming, but to a computer, this is like the easiest thing ever. And that actually means when it comes to computers using calculations, they love matrices. They're organized and they're quick for their calculation purposes. For us, not so much, but for them, it's easy. So I'm going to do a 2 by 3. So when you make a matrix, you have to do 2 by, and then hit enter, or hit to the right, 3. Got it. And then you can start filling it in, negative 3. This is going to be my matrix. You know, I could have used, what would have been kind of cool is if I go to matrix and call it C and D. That might be nice. I don't know. Would that be more fun? If I go edit and call it C. If you want to edit matrix C, you just go down to C and hit enter. Make it the right size, 2 by 3. And then start putting in the numbers negative 3, 4, 2, 5, 0, 4. And remember, I can't put in negative, so I'm going to do it a different way. So would you take a second to enter it in your calculator, see if you can make it happen? C and D. Because after that, I'm going to let you guys find the rest of them on your own, but I got to give you some backup data. Okay, enter in the calculator, rock and roll.